So we've had 10 years of discussion. And what is interesting to me is the last 10 years, you had only 1, 2, 3, 4 months, sorry, 6 months where the rainfall was well below the normal. Okay. So you have a total of 40 months, just 6 months were normal. And if you look at the flood events in the market, you only yeah, you have only 1, 2, and 3. So the extremes are rare in monsoon. Most of the time is normal. And look at the Pacific Ocean conditions. There are 1, 2, 3 La Ninas and 2 El Ninos, and it is sort of okay, but actually more La Nina than El Nino. And some of you attended Srinivasan's seminar yesterday would have learned about how the transition takes place. Okay, so you see that in this entire 10-year period, we had one clear drought, that is 2015, which was predicted correctly. And 970 in 2019 is the one real flood. So rest are all, if you go by one standard deviation, is more or less normal. Okay. Now, if you look at what happened in the Pacific Ocean in this period, we had one clear El Nino in 2015. We had one in 2018, but not during the monsoon season. Okay. At this time, it developed a little later, so its impact was minimal. Then we had 1, 2, 3 La Ninas, okay, followed by 1 El Nino. And if you recall last year, all the models said there will be a La Nina. It didn't happen. Okay. So that's why what Shekhar presented yesterday was very important. The transition that occurs is not fully understood, and most models don't get it right. Now, let's see how good the forecast of IMD was. 2022. I would say by and large, okay. The best was the prediction of 2015. They made correctly. And it was a courageous prediction because normally they don't do that. Normally they don't predict drought. They predict normal plain safe. But that year they didn't predict drought, and it came out right. But I remember that till August 15, monsoon was normal. And it created some, what do you call, Oregon to sky map. But ultimately, IMD came out right. Next year, they went wrong. Next year, they said, La Nina, it will rain a lot. It didn't rain a lot. Okay. It was below normal. And other years are okay, fine, why? All the way to 2019 was an extreme September case, and that they got it wrong. 2020 signed right, very close to normal. So there are a few cases where the model couldn't get it right. Okay, now this year started with 2 surprises. One was the May rainfall. Okay, see, May rainfall is normally about 60 millimeters. This year it was 127. Okay, double the normal. And I don't think anybody has a reason understanding why. Okay. And if you look at the record, there are only 4 years in the last 150 years or so where we had rainfall in May above 100. Just 4 years. So this is after almost 50 years. Sorry, 45 years. So 35 years. Okay. So this is very unusual event, and it is just not. Sometimes it happens in South India. This is almost all India. Okay. So there has to be some large-scale future, but so far I have not seen anybody come up with an explanation. Okay, now let's see the state of the monsoon in May. Just to give you in May, this is what sorry, the old one should have gone to 31st. So I think I put wrong. Yeah, this close 100% on February 31st. But the key point is that Northeast was normal. All the abnormality came from India. Look at this. almost 5 times. South India, of course, we also it was almost double. So Central India, as a matter of this is the kind of unusual rainfall in May creates confusion in agriculture. People start planting and starting something, and you have to warn people that don't do it because things can change. Okay, onset date was prayed to be 20th May plus or minus 4 days. It happened on 25th. And this is always a problem that we have a statistical model. It fits within this. But there are years like this year where after the onset over Kerala, nothing much happens. Okay? So I personally believe that one should not talk about onset over Kerala, but talk about onset over Central India. That is what is really relevant to India as a country. Okay? Kerala onset is a local phenomenon. They can announce it at the state level, but it has no relevance to the All India onset or to the All India rainfall for the whole season. But this is a practice going on for more than 100 years. I don't think they'll stop it. Okay? So, and what happened? Why did the onset occur? There's a clear indication that an MGO passed with overall data. MGO passed by around this time, 1 few days before, and then the trouble said once MGO went past and went past the maritime continent, it caused a descending motion over at least here South India. And that is connected to the what you might call breakneck-like condition. Now, it's not that simple. I'm sure there are people who argue that that's not the only cause. What happens is, if whatever triggers a reduction in monsoon rainfall, immediately there's a possibility of dry air coming from mid-latitudes. That also has also happened. So which came first, which came later is not clear as of now. Somebody may analyze it and tell us. Okay. Now the interesting part is that not around 25th May, it just jumped across Kerala, across Maharashtra, and then just stood there. Okay. So now for 9 days, the monsoon has not moved out of this condition. That's because it's raining like crazy here. Okay. This is what is called hiatus of the monsoon, and there are people who are studying this in some detail. Okay, let's look at the condition 2 days before. As seen in Windy, you can see there's a depression and heavy rainfall around Red Bay, as it were, Bay of Bengal, North Bay of Bengal, and that may or may not have caused this completely lack of clouds or most of it. So Albar is very amusing that IPL decided to hold a match in Ahmedabad on 1st June and it rained. Okay, luckily the match was held, and there was a rain predicted yesterday. Luckily, it didn't take place. So that's very interesting. If you look at the windy data, that rain comes from very low clouds. I can't really understand it. It's more like 3-4 kilometer level cloud, not deep cloud at all. Okay, but it gives enough rain to spoil a sports event. Okay, this is the today. Nothing has changed. This is I at about 2 o'clock. I see no change at all in the condition here. Okay. Everything is a little weaker because there's a one into the land, so it's not so strong, but no sign of its revival. So let's see what kind of forecasts are made for this. Now, if you look at GFS data, I see a clear sign of air, including here at 700 millibar. I chose 700 because 850 is close to some of the peaks of the Himalayas, so you chose a little higher. So 700 millibar clearly you see air coming from Afghanistan and Iran and so on, and also something coming through Pakistan. So this surely will not allow water vapor to build up this situation. Now let's look at the rainfall. This is up to yesterday. I thought I had also today maybe. Today also they announced that I think I have another maybe. So this is all India. looks nice, normal, but if you look at East and Northeast India, you can see how high it is, about normal, and South India is very low. So average of India, it looks normal, but it's very skewed distribution. Okay, it does not change today. Today also I saw, but I don't have it here. Oh, I have it here. Okay. So now I'm showing you up to 4th June. This is Central India, East, Northeast India, and South India. You can see both South India and Central India are not doing too well, while Northeast and East are doing very well. So this some would argue is closer to a break, but I don't think this is a classical break as defined by Joseph and Srinivasan and others. Now this is the 1st to 3rd June rainfall. All India is 10.9, now is 8.4. But the distributing it clearly. Interestingly, in spite of all the pictures there, because of the way that they got our culture, these are all normal, many of these places. Only South India is in bad shape. Focus is very high. So 1st to 4th June, you can clearly see the table here. If you forget the All India, only these two sectors have 100%, 80% above normal, and these two are 50% and 30% below normal. So this clearly shows All India is not very meaningful in such a heterogeneous situation. Okay, what are the forecasts like? If you look at the forecast made on 21st May, okay, it was showing nice rainfall here this week. That is 5th June or even this week. Both these weeks, it's showing rainfall, showing some decline. But look at the next forecast. It was a week later, you want to. Okay. Within 1 week, you have to compare this with this. This is 50-12. This is also 50-12. Yeah. So it's so much different. Just in 1 week. So the question I have is, how come in 1 week, what changed in the initial condition input that you went from above normal to almost well below normal? Okay. So I suspect this is due to the way the models MGO. You will see why. Okay, so this was a June forecast made in April by IMD. Now, as of today is only 4th June. I wonder whether they will meet this situation where most of India is above normal, only parts of Karnataka and Tamil Nadu, Northeast. So it is still doubtful. Let us see what happens. It can still change after 15th June. Really, if the rainfall picks up and makes up for this deficiency, it might. But as of now, this doesn't look promising. But I can tell you later. I'll show you almost all the models, ECMW of whatever you have, they all show same. Okay, so this is interesting, but all of them are wrong. Okay, now I just picked up one website, and I forgot the name of the website. Interesting website, which predicts rainfall over Bangalore. Okay, see today's rainfall. It's running a little bit, but not that much. Okay, look at the and they're shown 1, 2, 3, 4, 5, 6, 7, 8 models. Okay, and 3 of the models predict more like 40 millimeters. 1 or 2 predict a few millimeters, which is not much. Okay? So there's a clear difference of different models. So I would say that city level forecast is still very tough. Although you get nice mobile application and look at it and enjoy it, there's no value. Okay, now let's look at what is the situation for the next 10 days. And this I had to fight with IMD to get it. If you recall, last year they stopped it around August, September. So I pleaded with various people and all over the place. Finally, they agreed because they felt it is not useful. Now, I want to tell you this is a matter of perception. If you are a synoptic meteorologist forecasting for tomorrow's rainfall, you don't understand the value of All India. So All India doesn't fall on your head. Only this rain is falling on your head, not All India. So the person says, why put this? But this is of great value for people in academics. You are interested in how good the model is in getting the active break cycle of the monsoon. And one measure, not the best measure, one measure is all-India rainfall. I would have preferred the MCCZ, but that's not available. So all-India rainfall tells you clearly that for the month of June, although these two days look good, but really up to around 11, it's not really, although it's above normal, it's kilometry, but really it's not taking up till about 13 June. Keep that in mind. Next week you will see how good it is, because it's not clear. I will show you ECMWF. It does not agree with this forecast. Now here is the ECMWF forecast. On 15th May, almost 3 weeks back, they forecast very well above normal rainfall here. Okay. That's not happening. This 15th May. Just a week later, or 5 days later rather, this is their prediction. Same period. Okay. Both are 2nd June, 9th June, middle of this period we are in. And see the sudden change from above normal to below normal, and then just in 5 days. So I'm surprised by that, because all these models are accumulating real-time data. Okay. So what happened between 15th and 20th May that changed the result so much? So there has to be a large-scale event. I suspect MJO was one of them. Now this is the forecast for the next. Now this does not agree with IMD. They're still saying maybe normal year, below normal year. They are not showing real revival. This is up to the 20. If this is true, unless something happened in the last week of June, June will not be above normal. Chances are very low. Now, this is the prediction for, that's what happened here. Yeah, this is 3rd June prediction. Yeah, so you must compare what is showed here with this. This was predicted on, sorry. Yeah, this was predicted on 20th May, okay? Then I looked up more recent one. Look at the bottom, 3rd June. Okay. So based on 3rd June, they are saying that from the last week of June, not last week, the 3rd week of June, there will be above normal rainfall here, which will partly agree with IMD forecast. And this is the next week, 3rd June to 7th July. Again, they're saying there is some system over central India. Okay, let's see some of the forecasts. This is GFS in US. 1st to 7th June, completely blank, which is okay. This is what we are seeing right now. And Northeast is above normal. And next week, it is showing some activity South India, but nothing North India. And then I saw another interesting website. There's so many of them now. These are qualitative. They don't give numbers. Okay. And what interests me here is, in this website, they are saying both from 4th to 10th June and 11th, 13th June, India is under deficit. So their cover bar is below here. Now let's go back to what happened last year. Last year, there was spectacular failure of all models who made a linear prediction did come through. Okay. And so you can see that all of them are well below observation. Whole thing, some of the -2, -1, -0.5, it barely touched 0.5 and went back to neutral. So this is a problem that Shekhar has looked at his thesis, the transition from one phase to another phase, especially when you look at the month of March, April, May. That's when the most difficult prediction is. Okay? So you see that instead of going all the way down below this, it went and then went back to zero. Now let's see the forecast in May by CFS V2. I find it very amusing because it's all over the place. There's a La Nina and El Nino and large spread. So either it's a model problem or it's something showing something really uncertain about the forecast at this time. Okay. So this is two largest spread in my opinion. Let's see ECMW equally bad. Okay, I don't think there's any difference with these two. They're going from plus 1.5 to minus 1.5. Yeah, ECMW has a closer, what do you call, little clustering closer to 0.1. But the answer is larger, CFS had the largest spread. Now this is IRI, which is standard thing people look at. And here you can see that if you look at all the models, all of them are just sticking to statistical or dynamical, or all of them are. So this is going to be neutral to neutral, okay? And if you look at Arindam's paper, which he published many years ago, this is the most common transition. And the chances are 80% that will be a normal year. And you see in the forecast, I'll talk about very soon, most models sort of agree that it's been normal. Okay. Now, to me, when you're in a neutral phase, that's when you want to understand the role of other parts of the ocean. Okay. So to me, this is what is very important. What we're learning them wrote a paper in Monsoon. This region, which has impact on the Indian monsoon, and you have an index which had this, and this. Okay. So this year, this is close to 0. This right now 0, it might change. I will see that. So to me, this may be the one which really has an impact. So I don't know, not here now, but next week I'll ask him to give us some data about what is happening, how his, what he calls IPSL, how that will predict this year's June-July rainfall. He has a model for only June-July. Okay, now, in spite of all the problem with neutral, and so the key point is that the PDO right now, you look at that figure I showed you, PDO is still negative. It's because of long-term oscillation. This is a sign of a negative PDO. Okay, this one. And what is that? So if you look at this picture, you realize that you're in the negative phase of the PDO. And since it's an oscillation with a longer time scale, it may have impact on the Indian monsoon. And maybe because of that, it may be either normal or even can be below normal, above normal. Now, you look at ENSO, we are still close to neutral here. Okay. And if you look at PDO, it's well, very negative. Okay. Although people don't, because the PDO has a long time scale, people don't like to show the latest value because you have to average a couple of months before you get a data with no noise. Otherwise, very noisy data. Okay, so PDO and ENSO have very interesting thing. Both have peaks in the 4 to 5 year rate. And ENSO also has peak 2-year rate, sorry, 3-year rate. But PDO's main thing is this 70-year peak. And otherwise, it's confusing because this is very close. ENSO and PDO's peak in around 5 years. Now let's look at the energy budget of the Pacific, and we came to El Nino here, where it's very warm, and then it started losing heat, so it became negative warm water volume, and that's why temperature goes down. So all of us thought to go down here, it didn't. It sort of hovered around this region. This part is a little confusing though. I got it replotted. It shows up more nicely. You can see then after rapidly going down and not going all the way to 1, it recovered. Okay? So these are the kind of changes that the models are not captured. So there is some problem in correctly modeling advection of warm water from somewhere. So this is where the models are having trouble. Actually, I've not seen anybody seen a paper which shows models having a similar phase diagram. I have not seen. If you have seen it, tell me, I will have a look at it. How could the model get this whole phase diagram right? Okay, how about IOD? IOD forecast is for this is from the first area of 100, predicting a negative IOD by July, August, September. Okay, not a good news for India. So, but the forecast capability of IOD is not very good. Okay, you look at the past history, ENSO forecast is superior to IOD forecast. Okay, but my concern with IOD is that it is so close to ENSO variation. I don't know how you can separate it out and have it as an independent parameter. So there are two problems I have. One with the fact that it seems to be linked to ENSO. Secondly, it comes after July. So to me, it has no value. Comes after July, so maybe it's caused by the Indian monsoon, not the other way around. So you can see most of the time in the 40 years of data here, I don't see an independent IOD behavior in a year where ENSO was not there, for example. Maybe one or two out, maybe say there's one example here, maybe this one. Negative value. Yeah, positive, I don't see anything wrong. Negative, there is some possibility there, like this here. So when ENSO is neutral, maybe IOD has an independent character. Okay, now let's look at the forecast of not IOD, somehow ECMWF has a forecast for the Eastern Equatorial Indian Ocean, EEIO, okay? Because that is more important than the other, I think. So their forecast is remarkable. They're saying by degrees Kelvin every, they're saying close to 1 degree Kelvin by July, going to 1.3, 1.7, and so on. Okay. So this is consistent with what you saw earlier from APEC forecast. Okay. And is well above the natural variability of the model spring. And ECMWF is very good. They have 100 runs in which they do. So they have good statistics going with them. But you'll watch it, they'll change it. They'll change it to June 1st, but they do it after 5th June. So next week I'll show you how much it has changed. Okay, this is a forecast from NCMWF, which Ravi gave me. And it agrees with others that you're going to see maybe a weak La Nina and a negative IOD. Now let's come to the seasonal forecast of IMD. They make two forecasts, one in April, one in May, and nothing much. They almost same. I don't know why they do it, but there's hardly any difference. Only difference you see right here. 31 became 30, 8 became 9, 30 became 33, 26. So they are made no change. But in comparison to climatology, I would say this is remarkable. They say the chances of it being 100 is twice the climatology. So let's see whether that comes out true, whether you are in that range or not. And even this, I would say, is pretty high. But it's not double, it's 50% more of 1810. Maybe the model predicts a La Nina. So next week, Dr. Rajendran will talk about the CFS forecast. You'll know more about what model is doing. Okay, they also give regional forecasts, which I'll just present it here. I'll discuss it at the end of this monsoon. And what is it saying? Northwest India, normal above normal. Central India, normal above normal. Southwest India, property forecast I'm very surprised. Let's see. Yeah, so, yeah, sorry. Look at this. 76 probability that 106. So we have to see. So May is gone, that May doesn't count. June, July, August, September. Unless something happens later, I'm really supposed to that number. Northeast India, they are saying below normal. And this is the monsoon portal, which is what we should be focusing on. Again, higher chances of more than 100%. Okay. Now, this is the JJAS forecast, probability forecast. Again, very similar to June. Most of India is above normal. Kashmir and Northeast are below normal. Now, this new element has come in. I like it. They are giving numerical values for each of the subdivisions. So this is good. I like numbers to be given. So at the end of this month, we'll see how many of them are right. So we can give some grade. Although, if you talk to Tim Palmer, he says one shouldn't give numerical values because it's all statistical, no point giving, only give probability. But I find the numerical value much more interesting to compare. So let's see whether, having given these values, let's see how many of the get it right. So we can get them a score, so grade A or grade B or grade C. Okay, now what about all India rainfall from ECMWF? Interesting, they got the May correct. They said May is above normal. I think this is millimeter per day. 0.1 millimeter per day, which is not that high. We have 60 millimeters over, we have 30 millimeters over. June, they are saying almost 1.4. So that I have a doubt. July, August within the model noise. Okay. So this is the key issue. Whether June will be so much above normal as they did. But next week I'll show you the 1st June forecast. We'll know whether they correct it or not. Okay, let's look at CFS-V2 spatial pattern for June, July, August, showing a slight above normal near Orissa and Madhya Pradesh. They'll go normal here. That means Kerala will be below normal in June. Now this is, I forgot who is this, NCOWF, which Ravi gave me. And this is JJAS showing above normal in Central India and East India and below normal in South, especially the coastal regions. Okay. And they're giving millimeter per day, so we can check it at the end of the season. This is CFS-V2 June index condition. Sorry, May condition for June. They are showing high rainfall in Central India in millimeter per day. So far, doesn't look promising, but we don't know. Next 2 weeks, it remains a lot in May. This is GFDL, May condition, June value, and showing whole of June. This, I think, they won't get it right. This dipole behavior is very impressive, but maybe no. And this is CFS-V2 May condition for July, not June, July. And again, very interesting dipole structure. Let us see whether they will come out right in July. And this is GFDL, different from the previous one. Large negative anomaly over Northeast and Eastern India. Okay. And this is from, I believe, APEC. They give a distribution, and this is June to August, and I don't see any relay signal there. 39, 34, yeah, normal is 39. Now let's look at spatial pattern. It is similar to all the other models. This is a multi-model ensemble showing most of India. I think this is June, July, August, I think. I can't see it here. Okay. And this is probability-wise, again, above normal. Other one was millimeter per day, this probability. And so June they are showing it above normal. So sorry, this is September to November. I'm sorry. Let's what is the other one? Okay, I missed it. Okay, I'll go back and check it again. Now this comment made more than 12 years ago. I think I want to read this paper, interesting paper, based on a lot of analysis. They're saying South Asian monsoon is not a slave to the forcing from the equatorial Pacific, although it interacts with it. So what they're saying is it's a two-way interaction. You cannot just use that to predict this. This also influences that, and that's a thought that I think people have to look at more carefully. Now, based on what Shekhar presented yesterday, he presented a model for the Southern Hemisphere, what do you call, oscillation, essentially, which governs how the answer occurs. But I recall that a lot of people were not happy with the SO index. SO index came historically, almost 100 years ago, because there are two stations, one in Tahiti, one in Darwin. Darwin and Tahiti, both of them were not along the equatorial belt. Darwin is around 12 north, Tahiti is 12 south, Tahiti is 17 south. So a lot of people are not happy about it, having a oscillation index, because if you look at all the papers on the oceanic component of the El Nino, they focus on 5 south, 5 north, or 10 south, 10 north. Okay, so it's ideally thought of as a worker circulation anomaly. But if you're looking at something beyond 10 south, you should not. But I think it is nitpicking. The fact is that, yeah, this would have been nice to have, but you have no stations there, except maybe recently. So people have compared this index with they call it equatorial SO, technically correct, with SO. They compare quite well. There is no difference. Okay. Now, I also want to show you a recent new plot given by IMD, which I like. So this plot is more meaningful because it shows why the monsoon cold zone is chosen this way. If you only want to choose regions which are at least 800 millimeters of rainfall from June to September, then this is the right place to choose this region. You don't want to choose south, you don't want to choose this region. So this is the logic for the choice of the MCZ. Although there are more complicated statistical analysis to compare how they coordinate with others, but by and large, the core high rainfall region is your focus for the monsoon. And secondly, remember, this region has not much orography. The problem we have is if you mix up Northeast and Kerala with India, you are in trouble. Kerala is influenced by orographic rain, so is Northeast. So adding this completely confuses the physics. So from a purely academic perspective, we have to stick only to the monsoon zone because it's more or less flat. There is no rain. So now, right now, for example, look at this. First thing I've seen this variation. The highest rainfall in June to September is not in Kerala. It is in Karnataka and Goa and maybe part of Maharashtra. Now, if you go and look at the meridional variation of the zonal wind, is maximum here. Okay. And the reason why I like to look at this because when Rajendran will talk next week, he did a modeling effort in Japan, how global warming influences monsoon. He showed clearly the jet shift, okay, by about 5 degrees. And that's enough to reduce Kerala rain. So almost all global models with a high resolution predict that Kerala's rain will decline in the next 50 years. Okay, and it's already seen. If you look at the data last 50 years, rain will decline, but no one notices it because rainfall is very high, 10, 20 millimeters. You don't worry about it because the trend is clear. Okay, so this is the role of the jet. The jet is pitching on this Western Ghats, determines the rainfall, and wherever jet is high, rainfall is high. But one more thing which I was interested and it turned out to be not simple. If you think of this wall as a solid wall, then we can explain this low rainfall as the lee side of the mountain. Okay? But on a day-to-day scale, it doesn't come out right. When it rains in Mangalore, it also rains in Bangalore. So that worried me, but the real reason is more complicated. It is not a wall. There are lots of gaps. Like the Palghat gap in Kerala, which is very special. There are gaps in the Western Ghats in Karnataka and Goa, and the water river goes through it. So water river goes through it, you will get rain on the sub, but you can explain most of this low rainfall as the lee side of the mountain. But if you saw a much high resolution plot, let's say you take a 1 degree plot, or even you can look at ERA 0.25 and check, you will see a very low rainfall here, right next to the Western Ghats. As a matter of fact, I remember more than 40 years ago, some of the farmers in that domain, just East Western Ghats, they were complaining of drought, and IMD would not accept it because there are no rain gauge there. Okay, so this is a problem with rainfall. It has to be a very high resolution of the order of 10 to 20 kilometers for you to capture the spatial variability. Okay? Now today that issue has become very important. You know why? Because the Indian government has decided to insure all farmers. Government pays money. Okay, like all the subsidies we are getting free water, free electricity, and so they are insuring the farmers for failure. But for them to get insurance money, you need a rain gauge every 10 kilometers. Otherwise, you cannot predict. Usually, if somebody had a normal rain, it will have a drought. So this is a challenge. I hope IMD will meet it and put more rain gauges in, especially in orographic region, where definitely just this is definitely very low rainfall. I think I have one figure, so drawn by somebody, which I have it, I'll show it next time. When the resolution is very high, you can clearly see the low rainfall just to the east of Western Ghats. Okay, so this is a monsoon core zone that is logically related to this figure. Okay. Now, I just want to talk about this transition part, and Arindam wrote a paper. Now, there was one paper written last year, in which Rajin was one of the authors, and the plot they have done this way, I find it very convenient, which is that they plot the DCF and the subsequent KGF. So, if you go from El Nino to El Nino, you are in this block. If you go from Rajina to Rajina, you are in this block. And if you go to El Nino to neutral, you are here. And we are this way here. From neutral to neutral, we are here. And what surprised me here was the number of points is not that large. Yeah, this was only 52 years. There were only about half the points here. So what it says is the probability that a neutral El Nino in DCF will become actually El Nino is not small. This is surprising. I want to look at it more clearly. I thought it would all be here. But at least 3 plus 4, 7, 8, because there are 9 points here, which were neutral here, but they are El Nino. So let us see whether this is one of them. So whether that will happen or not, you have to look at the work done by Shekhar on transition mode. You have to know whether this year the El Nino transition mode has the capability to make trends or not. Okay. So whatever results we have till now shows that it is almost zero. So it's not going to help you or hurt you, right? So it's going to be. So his prediction would be based on the data will be here. Okay. Now this is a figure which is very nice that Shekhar showed yesterday, which is the what they call El Nino transition mode. But I think that since it is based on pressure, I would like to call it global southern oscillation, because it's a global picture, half the hemisphere, not full hemisphere. And I'm sure, and we can ask Shekhar to do it, if we compare the spectra of the GSO with the southern oscillation, equatorial, I'm sure it will be similar to between PDO and ENSO, similar structure. Okay. Huh? Okay, you have done it. show it next time. We'll have to look at it. Okay. So this is a nice picture. The paper has been published recently. I'm sure you'll hear many more things about this way of looking at it. This is just based on pressure as a parameter. And this is what Arindam has been doing for last 10 years. He had a similar system for modeling onset. Okay. Now, I like this because of all the parameters we deal in meteorology, the two most reliable are SST and surface pressure. Surface pressure is the weight of the atmosphere, nothing else. Okay. So to me, if you can base your forecast or your understanding based on surface pressure and temperature, you have a very robust method of doing it. Okay. So this is good direction. Let's see how far this can be carried to understand the transition of ENSO. Okay. Now this is the figure he showed yesterday, which I like very much. So he's showing that ETM index favors La Nina 1, 2, 3, 4, 5, 6, 7, 8 times in these 25 years, and 1, 2, 3, 4, 5, 6 times, and the rest are all close to 0. So one can explain many of the La Nina lines here and here in terms of this. And he has also put another paper, which I'm not able to get hold of, which is comparing CMIP models with this and showing that not all models capture this ETM correctly. Okay, so if this year is going from neutral to neutral, based on this climatology, we can see there is 76% chance. So 100 events are there, neutral to neutral, and very good chance for this figure. A small chance of hell and also a small chance of low. So that's what the past data shows you. Okay, so this has to complete this. This is a IISc that Arindam wrote about, and their index this year, in the month of May at least, or even June, this will close 0, this will close 0. So this year, June there should be influenced only by these two. Okay? We'll find out next week whether Arindam tells me what is the number like. Okay, so I'll stop here. Any questions? Yeah.
Is very important. Is okay, so let us simply go from
Yeah. Debate on this long time.
Yeah.
Then people there's not argue. That's it. Tropical years start with the onset of Indian monsoon. Tropical year, not just and you don't care about it, but nobody listens to it. Because I think it is not possible to define the person. You and I will fight over it. So a current region is unsafe. But for example, we have seen the last 5 years, monsoon extent beyond 30 going into October. Okay? So that's a problem. Yeah. So unless somebody comes up with a I think one island comes up with a website in which you use the water vapor. I believe water vapor is a more reliable measure than rainfall. So it is much less noisy. So based on water vapor, we define the index. And that can be extended from May to. But rainfall is not very noisy and the data is affected and so on. So I would like to see something constant. If you look at what number answered by IMD, water vapor alone is not enough. Although ISRO can come up. ISRO because what is satellite data, they find answer in terms of what we have in the heritage. But the argument they are very big. Just look at all the years, some years what we have made. So they are saying they want to make it right, be what we have to make all down to be wind, not so rainfall, all of them. Okay, so another question. Yeah.
Mentioned El Nino as well as let's say IISc.
Yeah.
So the question is, you mentioned North Pacific has a role to play in networks.
Yeah.
In respect to dynamics or mechanism with which it can now affect.
The point I tell you right now, all the work is coordination based. Coordination based works well to national program. So I would like more of the students to actually run models. Put some blog about specific. This kind of what people are not going to favor of, because we look for you must trust your models. First, we are going to model with the Indian motion correction. You should get to 8-7 millimeters. So then get to that, throw it away. No problem about it. Then the tough task. Okay. If you look at all the Indian models, very few get both the mean and the variance correction. Absolutely none. I don't know if anybody knows, tell me. I don't know how many models get 8-7 millimeters, 8-9%. Nobody gets it. So if the variance is wrong, mean is wrong, okay. That's the problem. But I still believe that as the model is increasing year by year, I think the cumulative things are slowly getting better and better because there is now convection permitting simulation. So I think the more recent models will be useful to study. Now I'll tell you why I'm saying that. You will see in the next few years, AML will make a better forecast than all these models. But AML is trained on these models, right? But not only AML has this, we have now 25 years of satellite data. I merged, very high resolution, 3 over 8, right? So, 300 over half an hour. Not how good they are, but half of them. So, we have 40 operators per day, 15 kilometers, right? 10. Yeah. So, imagine how much data you have. So, 24 years all the data. You take all the output of the model and do brute force of AML and correct the model to against observation. It's good, right? But you don't know what happened. It's one big black box, it's right out of the model. Okay? This is going to happen, I can like it. Because academic, I love to understand the physics. But AML is going to unfit for that. As one time, we have called Professor Srinivasan from IISc to talk about it, but he's not well. I hope he recovers. When he comes, he will talk sometime this month about the use of AML, the use and misuse of AML. The key about which he's interested in so-called explainable AML, that you can use that to understand what's going on. If you don't do that, it becomes a black box. But those who are involved in forecasting, they don't care for physics. I don't blame them. If you're forecasting tomorrow, you don't worry about it. So I think the scope for AML is very good because we have got a very good rainfall data. And there are lots of models available. So if they can take one model and train it against that data, make all the corrections, they'll get it right, not 100%, 90%. This is not bad. But they'll fail occasionally because the model cannot capture certain features. For example, all of you know that 1,000 millimeter rainfall in Mumbai in 2005 is very difficult to get. Not a 1,000 millimeters, a gradient of almost 100 between Santa Cruz and Kola. And that is amazing. And white matter. So no model yet got that gradient. But AML is going to come and the advantage AML is going to be all you can run it in your laptop. You don't have to depend on IMD. This is what is nice about it. But if you don't use it, you learn more about Monsoon. It's lottery. It doesn't name with lots of numbers. But it's coming. Very likely to know.
Is there other question?
No.
Can you experience?
Huh?
Can you experience?
No.
July or August is more important or June or August? In what ISMR to be normal year?
I don't know.
In terms of normal year, ISMR. July or August is more important or June or
I nothing in July. In July, I'm not saying that here the July is paid on the normal. Okay, but remember, this is the complex system.
Yeah, it's muffled.
Oh,
Probably not holding their mics
But I'm
properly.
not seeing the monsoon or the same in July. But I think we are going to a global warming phase. So September rainfall has always above normal the last 5 years. It may make up a July, that's possible. But what I remember is before this period, July, August defined the Indian monsoon, not during the. So as a matter of fact, I did not present paper showing the June is irrelevant because Then you have to consider almost nothing. Only July, August, September. And you know, July, August is so high that if September doesn't make up, they have to be like 2019 program. That's very extensive. Double the number. That's what we have. But you know, the competition for number them happen. But most of the time, if you're out of your normal, there's no way you can do. Thank you.
Is he still speaking?